Hey guys, let's try number 6 of the 2015 AP Statistics. Okay, so this one is going to be very nice. Corn tortillas are made at a large facility that produces 100,000 tortillas per day on each of its 2 production lines. The distribution of the diameter of the tortillas produced on a production line A is approximately normal. We can see that it's right here. And with a mean of 5.9. So that's our mean. And the distribution of the diameter of the tortillas produced on line B is approximately normal with a mean of 6.1. Now you could just measure it right there. Here's 5.9, that's your mean. Here's 6.1, that's your mean. The figure below shows the two distributions. Great. The tortillas produced at the factory are advertised as having diameters of 6 inches. For the purpose of quality control, a sample of 200, okay, so let's just see what that is. A sample of 200. Remember, the 100,000 is what it produces per day on each line. That's not the sample that you choose to figure out, the average and the standard deviation. So 200 tortillas are selected and the diameters are measured. From the sample of 200 tortillas, the manager of the facility wants to estimate the mean diameter in inches of the 200 tortillas produced on the given day. Two samples methods have been proposed. Take a random sample of 200 tortillas from all 200,000 tortillas produced on a given day, and then measure the diameter of each selected tortilla. Or method 2, which says randomly select one of the 2 production lines on a given day. Take a random sample of 200 tortillas from the 100,000 produced by the selection line, measure the diameter. So let's take a look at what that means. In method 1, they want you to take 200 tortillas from 200,000 of them. So they're putting both of these guys together, and you're going to get some from here, some from here. Now, with that being said, you may have an average of 6.0 when you're done, because you'll get some from here. Remember, the average here is 5.9 and 6.1. In method 2, it says randomly select one of the 2 production lines. So in that case, guys, then what would happen, let me get a bigger eraser. What would happen here is if you chose production line A, then the 200 would have an average of 5.9. And if you choose production line B, then the average would be 6.1. So method 2, if you only choose one of these, remember, the higher the n is, by the law of large numbers, you're going to get closer and closer to the true mean. So it says, will a sample obtained using method 2 be representative of the population of all tortillas made that day with respect to the diameter? So that answer is no. And I'm not going to write everything, but I'm going to say whichever production line you choose, the diameter will be close to that mean. So I'm going to say if production line A, it will be close to 5.9, and if B, it will be close to mu equals 6.1. So it won't be representative of the population. So that answer is no, and I hope that makes sense. Okay, part B. The figure below is a histogram of 200 diameters obtained by using one of the 2 sampling methods described. Consider the shape of the histogram. Explain which method 1 or 2 was most likely used to obtain such a sample. So think about this here. We have some tortillas. These are 200. If you counted every single one of these, so like this guy here is about 17. This guy here is about, let's say, 18. If you added up all of these, it would give you 200 of tortillas. Okay, so these are their diameters, and these are the tortillas. And now is it all concentrated around 5.9? Is it all concentrated around 6.1? It's concentrated around both of them. This is what we call sort of like a bimodal. It looks like this, right? So let's see which method that was. I can't remember. Method 1 or method 2. Method 1 takes a random sample of 200 tortillas from 200,000 tortillas produced on a given day. So you get some from there and you get some from there, right? We discussed that you'll get some from here and some from here. Method 2 says you're only going to select one of two production lines. So if it was going to be method 2, then all your tortillas would be surrounded either with 5.9 around here, all of them, or 6.1 depending on what you chose. But because it's both of them, this is going to be method 1. And the reason why is because the bimodal shape shows that it was in both production lines, okay? So whereas if it was method 2, it would only be around one of them, okay? So I hope that I don't have to write all that down, but basically method 2 would be a unimodal. It'll be approximately normal. Method 2 would be either him or him. So that's method 2. So this comes from method 1 because it took 200 tortillas from both of them. And so you're going to get a mixture of this and this. Letter C. Which of the two sampling methods, method 1 or method 2, will result in less variability in diameter of the 200 tortillas in the sample of any given day? Okay, so variability, we know, is the standard deviation. Now, we know that this is dealing with mu, so we also have a standard deviation, but this is mu of x bar. So in this case, we are going to use this formula here. Remember that mu is equal to mu and sigma of x bar is equal to sigma divided by the square root of n. So method 2 would result in less variability. I hope that makes sense because method 2 would either give you this guy all squished here around 5.9 or this guy right here all around 6.1. If you choose method 1, look at this variability here. It's spread out all over the place because you got some from production line A and production line B. So method 2 has less variability in the sample because its sample only comes from one production line. So because the distribution of the diameters are not the same for the two production line, then selecting it from both lines will have a bigger standard deviation. So the answer for this is method 2 would result. Okay, in less variability. Okay. Each day, the distribution of 200,000 tortillas made that day has a mean diameter of 6 inches with a standard deviation of 0.11 inches. For each sample of size 200 taken from one, describe the sampling distribution. Do you guys remember this? Mu of x bar is equal to mu, sigma of x bar is equal to sigma over the square root of n, and then depending on n, you talk about, so this is our center, spread, and shape. So mu is equal to 6, stays the same. Sigma of x bar is equal to 0.11 over the square root of 200. You guys will have to, I have a calculator here. So that's going to be 0.0078. And then since n is greater than 30 by the central limit theorem, the distribution is approximately normal. So that's how we describe the sampling distribution. It will be asked on the AP, guys. Okay, so center, shape, and spread. Letter E, suppose that one of the two sampling methods will be selected and used every day for 1 year. Okay, 365 days. The sample mean of 200 diameters will be recorded each day. So they'll take 200 tortillas each day and figure out what the, they'll figure out like, oh, I'll take a tortilla, that's going to be 6.0. I'll take a tortilla, that's 6.1, 6.2. 5.9, and then they'll do that for 200 of them, and then they'll average them to get you X bar, and they'll do that every day for 365 days. Which of the two methods will result in the less variability in the distribution of 365 sample means? Okay, so method 1 or method 2? Why would method 1 result in less variability in the sample means over the 365 days? Because method 2, roughly half of the sample means would be around 5.9 inches and the other half would be around 6.1 inches. I hope that makes sense. So remember, method 2 says select one of the two production lines. So maybe, let's say January 1st, you picked production line A, and January 2nd, you chose A again randomly. January 3rd, you chose B. January 4th, you chose B. January 5th, you chose B. And, you keep switching between back A and B. Well, if you choose 200 of them, if it's from A, you're going to basically get 5.9 because 200 is way bigger than 30. If you pick B, you're going to get 6.1. And every day, the sample mean is going to be either 5.9 or 6.1. So half of them, let's say 100 days, will be 5.9 and the other half will be 6.1. With method 1, the sample means will be all very close to 6 inches because in sample 1, which is this guy right here, this would be, let's just say, one single day. So you're going to be getting some here, all over the place, and you're going to get closer to 6 inches. So that's why, in this case, method 1 will result in less variability. Okay, I hope that makes sense. Method 2, some days you'll get 5.9, some days you get 6.1. Okay? All right, and the final part of F. A government inspector will visit the facility on June 22nd to observe the sampling and to determine if the factory is in compliance with the advertised mean diameter of 6 inches. The manager knows that with both sampling methods, the sample mean is unbiased estimator of the population mean. In other words, it's a great estimator. However, the manager is unsure which method is more likely to produce a sample mean that's close to 6 inches on the day of sampling. Based on your previous answer, which of the two sampling methods, method 1 or 2, is more likely to produce a sample mean that's closer to 6 inches? Well, once again, method 1 will produce closer to 6 inches because method 1, you're taking some from here, some from there, but all together. In method 2, you're only choosing either A or B for that day. If you choose A, this person is going to see that they're 5.9. If you choose B, the person is going to see that the average is 6.1. In method 1, you're going to get some of everybody. So that's why method 1 is better. So slow down the video, take your time and understand it. Also, the rubric is online. You can read it. But I hope this helps with the explanation.